Hi, welcome back again to Mrs. Thompson's classroom. We're going to continue our lesson on the summation and difference identities for sine and cosine. So let's just start by reminding ourselves of those formulas. Last time I showed us where the cosine formula came from and said that we could do a similar proof using that to find the sine formulas, but here they are. So take a moment to write those down if you need to. Pause the video. And we're going to show you how to use these identities. Okay, so let's do this first example. Now, one of the things that's going to be useful with this is to remember how to add fractions. So 5/12, remember, could be written as 3 plus 2. Okay, and then each of those is going to reduce like so. So if I put a pi on there, it doesn't change anything about the way I do that addition of fractions. And so what I end up with are two of the angles that we memorized from our unit circle. We know pi fourths and pi sixths. Okay, in fact, if we draw that out real quick, pi fourths, we had square root of 2 over 2. For both sine and cosine. And for pi sixth, cosine is square root of 3 over 2, and sine is a half. So let's keep that in mind. Now we're going to use our identity. So we know that we're going to write this as cosine of 3/12 plus 2/12. That makes 5. And so that's going to equal the cosine of pi fourths plus pi sixths. So now we're going to break this out into our formula. We're going to do cosine of both of those angles. Okay, this is a plus sign, so I'm going to do minus because cosine goes to the opposite there. And now we're going to do the sine of both of those angles. So I'll do sine of pi fourths, sine of pi sixths. So now we look at our unit circle and we replace these with their values. So cosine of pi fourths is square root of 2 over 2. Cosine of pi sixths is square root of 3 over 2. And we're multiplying those things together. Then we subtract and we go, okay, well, sine of pi fourths is square root of 2 over 2. And sine of pi sixths is a half. And I'm multiplying those two things together. And so now I have square root of 6 over 4 minus the square root of 2 over 4. And we could write that as a single fraction if we would like. Square root of 6 minus square root of 2 over 4. And this would be our value. Now this is exact. Square root of 6 and square root of 2 are irrational. So if I tried to do this on my calculator, it's going to give me a non-ending, non-terminating decimal that I would have to round off and estimate. But this is exact, okay? All right, we can also do this with degrees. So let's remember that cosine of 15 could be 45 minus 30. So I just have to find two of the angles that we learned from our unit circle. So these identities aren't useful for everything. They're only going to really be useful for values that I can relate to the things from my unit circle, or if I'm trying to solve some sort of equation or something like that, then I can use these identities there without precise numbers. Okay, so if I'm going to take this as cosine of 45 minus 30 degrees, this would be cosine of both of those angles. And then because it's a minus, we'll do plus the sine of both of those angles. Okay? So now cosine of 45 is square root of 2 over 2. Cosine of 30 is square root of 3 over 2. Sine of 45 is back to square root of 2 over 2. And sine of 30 is a half. So doing that multiplication, I get square root of 6 over 4 plus the square root of 2 over 4. And so I get a very similar answer to the last problem, except it's an addition. Okay, and a lot of these, because we know 30, 60, 90, 45, because of the angles that we know and the ones we can relate these to, all of these will have a similar look with the square root of 6s and square root of 2s. Those will be the common ones to look for. Okay, so let's do another one. This will also allow me to prove, this was our, looks like what we called our cofunction identity. So let's see if we can remind ourselves using this formula of what this would be. So it'll be cosine of pi halves times the cosine of x plus the sine of pi halves times the sine of x. Okay, now cosine of pi halves, this is 0. Sine of x, this part here, is 1. Sorry, I just wrote that on the wrong piece. Let's fix that. Sine of pi halves is 1. Okay. Okay, so once I simplify that, this all goes to 0. So I'm left with sine of x. And so this was our cofunction identity that told us that sine and cosine were translations of each other by pi halves. Okay. All right, let's do a sine problem. So pi 12ths, again, we could write sine of pi 12ths as 3/12 minus 2/12. 3 minus 2 is 1. Okay, now that reduces to 3/12 would be a fourth, and 2/12 would be a sixth. So now I can use my sine formula, which would go sine of pi fourths, cosine of pi sixths, and then sine of pi sixths, and cosine of pi fourths. And with sine, when it is a subtraction, it stays a subtraction. So now let's do each of these parts. So sine of pi fourths is square root of 2 over 2. Cosine of pi sixths is square root of 3 over 2. And I'll multiply. Okay, minus sine of pi sixths is a half. And cosine of pi fourths is square root of 2 over 2. So my end result, again, is a square root of 6 and a square root of 2 over 4. Okay. All right, let's keep going. Now we're going to go the other direction. So this is a sine times a cosine, and a sine times a cosine of these two angles, 20 and 25. So this would look like our sine identity, and because it's a plus, it would be 20 plus 25 degrees. So that's going to be the sine of 45 degrees, which is the square root of 2 over 2. So I didn't have to know 20 and 25's values. I just had to be able to add them together. Okay, the sine function has a similar cofunction. So I'm going to do this times sine of pi halves times cosine of x minus sine of x times the cosine of pi halves. So sine of pi halves is 1. And cosine of pi halves is 0. So this ends up being cosine of x, because this all goes to 0. And so this was again, our cofunction identity, that they are translations by pi halves. Okay. Now we can do this with tangent as well. We know tangent is sine over cosine. So this will be sine of pi halves over minus x over cosine of pi halves minus x. And we said this was sine of pi halves minus x, we just showed to be cosine. And cosine of pi minus x, we said to be sine. So this becomes cotangent. So cotangent and tangent are also cofunctions. Okay. All right, let's just go back and take a look at that. Yeah. Okay. All right, one more example here. If I take this sine function and I write it okay, now let's plug in the things that we know. Sine of x is 2/3. So this right here is going to become 2/3. Okay. Then we know that cosine of y is -4/5. So this right here is going to become -4/5. And we're going to multiply those together. Okay. Now I have to find their corresponding sine and cosine values. So let's remember here that I know sine squared plus cosine squared will equal 1. So this is going to tell me that cosine squared of x is 1 minus 4/9, which would be 5/9. So cosine of x is the square root of 5/3, and that would be plus or minus. But it tells me they are in quadrant 2. So in quadrant 2, cosine is negative. So I will keep only the negative. Okay, so now let's put that in there. So cosine of x is negative square root of 5/3. So that's going to go in as this part. Okay, and now we got to do this process one more time using the cosine of y. I know that sine squared of y plus 16/25 plus that 4/5 squared will equal 1. So sine squared of y is going to be 1 minus 16/25. So 25 minus 16 is 9. So I'll get sine of y equals the square root of 9/25, which is 3/5. Okay, now this is also a plus or a minus, but in quadrant 2, sine is positive. So I only need the positive of it. And so now let's put that in. And we know that sine of y is 3/5. So I'm going to come right here and replace sine of y with 3/5. And now we can simplify what we've got. So I'll have -8/15 minus 3 square root of 5/15. And so we could write our answer this way. Notice I did not have to find the angle. We could have used inverse sine to figure out what angle this was. We could have used inverse cosine to figure out what this angle was. But I didn't need to know that. I just was able to use my identity to get there. Now we can do the same thing for cosine. So cosine of x minus y would be cosine of x, cosine of y, plus sine of x, sine of y. So let's replace all of our corresponding pieces. So sine of x is 2/3. Okay. Cosine of y is -4/5. That's the green. And then we have, let's see, sine of y over here in the purple is 3/5. And then finally in our yellow, we have cosine of x as -√5/3. And then we can simplify that by doing the multiplication. So I'll have 4√5/15 plus 6/15. And so we can write that as a single fraction. And there's my answer to that one. Now, if I wanted to find tangent, then of course we could do sine over cosine and figure that out. Okay? All right, so hopefully that helps. We will continue on these in class if you're in class with me. But if you've got some questions, feel free to comment below. And I will see you next time where we look at our double angle formulas. So hopefully you can join me then.